Okay, so on function family applications, lesson 1.4, we're going to be using our function families that we talked about on 1.3, and we're going to be applying them in a real world scenario. So this first example, Eli sells hot dogs and soda combos at his high school's football game. He purchased enough supplies to sell 500 combos each night. He uses the equation P equals 5.5N minus 750 to model his profit P. So P is going to represent profit from selling hot dog combos, where N is the number of combos sold each night. Okay, so first thing we have to identify the function family. So if we notice, this is a linear equation. What aspects of the equation structure indicate that it belongs to linear? We know that based on this variable here. So remember, we talked about the other day, linear has a largest exponent of the variable. So the largest exponent is 1. Now moving on, part B, we're going to make a table to represent this situation. So if we look at our equation given, our X is going to be the N, which is the number of combos sold. And then our Y is P, which is profit. Remember, we talked about profit the other day. It's how much a company is making from selling a product. So in this case, we take the total sales, we take away the cost to purchase, or the supplies in this case. So the 5.5 times N is representing how much they're selling each combo for, and then they're taking away the 750, which in this case, it would be the supplies for the hot dog and soda combos. So this is your Y. So what we're going to do is, we know the number of combos sold cannot be a negative, so we're going to start with a 0. So if I were to plug in a 0 for N, the profit would be negative 750. So they would lose $750 because they already put that into all of the supplies. So then we could keep going to 1, 2, 3, but we know the max is 500. So on the table here, I'm just going to increase by 100, but you can do it however you want. So I'm going to go to the 100 next. So I would plug in 100 to get that Y value, which is our profit. So that's going to be negative 200 for the profit. And then I'm going to increase by 100 and go to 200 now. So all we're doing here is we're plugging in these numbers in for N on your linear equation. So that would be 350. 300 would be 900. 400 would be 1450. And 500 would be 2,000. So that would be the max profit there. Okay, so now what we're going to do, it says use technology to graph the function. So you can either use your own calculator, or you can use the Calculate 84 app. So we're going to go to the Y equals, and we're going to type in our equation that we were given. So 5.5, we're going to use an X, and then minus 750. Okay, so if you press graph on your calculator, then you're going to see a straight linear line, which we already said it was a linear equation. Okay, so you're welcome to change your window based on this scenario. So if you go to window, we're going to be looking at the X. Remember, X, the min is 0. It's going to 500. So I can go to that X min on window on the calculator and set it at 0. And then I can change my X max to 500. And then it says X scale. So the X scale is how much each mark is increasing by. So I'll just put it, since I'm going from 0 to 500, I'll put it at 100. If you make each mark 1, that's going to be a really, you won't be able to see your marks there. Okay, so then I'm going to go to the Y min. So I know my Y min is negative 750. And then my Y max is 2,000. Your Y scale, you can set it at whatever you want. So we're going from negative 750 to 2,000. So I'll just set it at 500. So there's no right or wrong scale here. So you should be seeing on your graph, you should see something that is similar to this. And we should have, it says label your axis. So X was the number of combos sold. And then your Y was your profit. Okay, so looking after changing your window on your calculator, you should be able to see that min point at the bottom and then that max point at the top. Straight line. So we're just sketching it. Okay, so then it says label your min and max values. So that minimum point should be 0, negative 750. And then that max point should be 500, 2,000. So basically we're looking at that table there. Or you can just look at the calculator. All right, so we're going to identify the independent variable in this situation. So your independent is your X, and we already said that was the number of combos sold. And then identifying the dependent, which is your Y, so that was the profit. So F, it says, are there any restrictions on the domain of this function? Yes. So domain was X. So yes, there are restrictions because you can't sell negative combos. So the number of combos sold must be positive. And then the max number sold has to be 500 because that's all they have. Okay, G, state the domain and range of this situation. So your domain is X, so we're talking about the number of combos. So we are going from 0 to 500. So you can either use inequality or interval notation. So I'm going to use 0 to 500. And we need brackets because it does include the 0 and it does include the 500. So your range, the profit, the min was negative 750, the max was 2,000, and then we have brackets. Now, on this scenario here, we clearly know that we can't sell decimals or a portion of a combo. So in this case, we would not want to list out every number from 0 to 500. So just know here that these are only integers between those two, okay? All right, so going to H, does this situation have a minimum? Yes. It says, if so, explain its meaning with the context. So yes, that point was 0, negative 750. And the meaning behind that was if you sell 0 combos, you lose $750. That's what the negative means. Okay. I, does this situation have a maximum? Yes. That point was 500, 2,000. So what that means is if you sell 500 combos, you make a profit of 2,000, sorry. Okay, well that's it on the notes. If you have any questions, let me know.